So we're going to do question 6 from the June paper you just did. Notice that it tells us that we have to show detailed reasoning, and part A is a show that question. So we can see we're doing some trig. So show that the equation 6 cos squared theta is equal to tan theta cos theta plus 4 can be expressed in the form 6 sine squared theta plus sine theta minus 2 is 0. So notice it's all in terms of sine. We've ended up with a nice hidden quadratic here. Okay. In year 12, you learnt 2 different identities to do with trig. So you learnt sine squared theta plus cos squared theta is equivalent to 1, and you also learnt that tan theta can be written as sine theta over cos theta. Okay. Right, so looking at this here, we have got different functions, different trig functions. So immediately I'm going to write things in terms of sine and cos. So I'm going to replace this tan theta with sine theta over cos theta. Okay, now that's going to be nice because that's going to cancel. I know that I'm aiming to get something only in terms of sine, so I'm going to replace my cos squared with 1 minus sine squared, and I'm going to use some brackets because I'm multiplying by 6. Okay, so now let's do some tidying. So we have 6 minus 6 sine squared theta is equal to, the cos's cancel, sine theta plus 4. And all we have to do now is move everything across to the right, or balance the equation, to make it equal 0. So we've got 0 is equal to 6 sine squared theta plus sine theta, and then 4 take away 6 gives us minus 2, and we'll just check. Yep, that's the same equation they've got, which is super. Right, part B, and they've drawn us a lovely graph there. They've drawn the left-hand side of the original equation and the right-hand side of the original equation. Okay. The diagram shows parts of the curves that were given, where theta is in degrees. Solve the inequality. 6 cos squared theta is greater than tan theta cos theta plus 4 for the range 0 to 360. So we're looking at where this graph, the 6 cos squared theta graph, is greater than the tan theta cos theta plus 4 graph. So where this one lies above that one. So I'm going to just sketch that on my graph so I can see what's going on. So we have to find the values of theta for which this little orange bit happens. Okay, so obviously we need to find our cutoff points, which are points of intersection. So those are the solutions of the equation 6 cos squared theta is equal to tan theta cos theta plus 4. Now we know we can solve that equation, this one here, is exactly the same as solving the sine quadratic. So that's where we're going to start. So for part B, we simply want to solve this quadratic for sine. Now you might prefer to write it as y is equal to sine theta, and the equation of 0 is 6y squared plus y minus 2, or you might just go straight for your sines. So I'm going to just use my calculator to solve it for me. So I've got 6, 1 and minus 2 as my coefficients. That gives me a half and negative 2/3. So I'm now going to cheat and use that to help factorise. So I've got 0 is equal to, so that will be 3y plus 2 and 2y minus 1, which gives us that y is negative 2/3 and y is equal to a half. Sine theta is negative 2/3 and sine theta is a half. Now they're completely reasonable for sine, it's between minus 1 and 1, so that's great. So we can now solve those equations. Okay, so if I use inverse sine of negative 2/3 on my calculator, I'm just going to check I'm in degrees. I am. So I would like to do inverse sine of negative 2/3, and I get negative 41.8 degrees. I'm going to store that on my calculator. And let's do the other one as well. You might remember this one from GCSE. Inverse sine of a half will give you 30 degrees. Okay, let's use our cast diagrams. You could use graph sketches. One for each of the two different solutions. Okay, right, so starting with negative 41.8, I start from the x-axis, negative direction is clockwise, so let me draw that in. I have got 41.8 degrees in there. I'm working with sine, and sine is negative, so sine is negative, not here and not here, so in these two quadrants. Okay, so I need to draw another solution in here. 41.8 goes there, always with the x-axis, and then I want to find my solutions between 0 and 360. That's what the question said. So we're starting at 0. The first one I get is going to be 180 plus 41.8. Okay, so that will give me 221.8. And I also want to do all the way around, so I'll just use different so you can see, going from 0 around to here, so I could do 360 take away the 41.8, and that gives me 318.2. Okay, let's look at the 30 degrees instead. So measuring from the x-axis, positive direction, 30 degrees. We're dealing with sine, and sine is positive, so it's positive in the all section and the sine section. So I'm going to draw my angle in here as well with the x-axis, 30 degrees, and I want to whirl around going from 0 up to 360. So starting from 0, first of all I'll get to 30 degrees, and if I start from 0 again, I'm going to get here, which will be 180 take away 30, which is 150 degrees. So we've got 4 values. Let's have a look back at the graph in the question. Brilliant, we've got 4 points of intersection. So my first one is going to be 30 degrees, 150 degrees, 220, let's round it to 222 degrees, and then the last one 318 degrees. Okay, so that means that I want to start at 0 and go up to 30. Now I'm not including 0 in my range of values, and I'm not including 360. Okay, so let's jot down our inequalities. So we've got that theta, black because it's easier to read, so theta is an element of, let's do some curly brackets for a set, 0 up to 30 degrees, union with 150 degrees up to 222 degrees, union with 318 degrees up to 360 degrees. And they're all curly bracket, curved brackets, because we're not including those values, because in our inequality we're using a greater than, not greater than or equal to sign, and for our range of values it's the same, less than signs rather than less than or equal to. Okay, so we can see these are the zones we want: 0 up to 30, 150 to 222, and 318 up to 360. Okay, I want to just check that I've got my values correct, so I'm going to type in the original equation. Okay, so in run mode on my calculator, I'm going options, calc, solve n. Okay, so the original equation that we're looking at is 6 cos, we need to put it in brackets, 6 cos x n brackets squared, and that has to equal Okay, just typing this in, I need to see it. Tan theta cos theta, so we'll do tan x cos x, and then it was plus 4. Okay, we are using x as our variable, oops, and we are going from 0 up to 360. And let's just check it gives us the same values. We've got 3150, 222, and then 318. Super. So that will be it.